Good day, class, and welcome back to your ESI 124N, your Engineering Mechanics 2, or your Dynamics of Rigid Bodies. And for today's lecture video, we'll be talking about the kinetics of particle, your work, and energy. So basically, this lesson is we're just going to develop no, the principle of work and energy and apply it to solve problems that involve force, velocity, and displacement. Of course, we are going also to study problems that involve power and efficiency and introduce the concept of conservative force and apply the theorem of conservation of energy to solve kinetic problems. Okay, so but before we proceed for our main topic, we just have to have that quick um, recap of what we have discussed last lecture video. So last lesson or last week, we talked about the planar kinetic of rigid bodies, involving the force and acceleration, and we did discuss there, on how or what are the equations of motions na kailangan natin na i-note, when we are going to solve a problems involving rotation about the fixed axis and also problem involving the general plane motion. So basically, just na-focus lang talaga dun sa equations of motion, and I hope di nyo na-forget ano yung mga equations of motion natin there. Okay? So, to proceed for our main topic or main lessons for today, here here are the lesson contents for today's lecture video. So we're going to talk about the work of force, a principle of work and energy, and lastly the principle of work and energy for a system of particles. And for our learning outcomes for today, you're going to explain the concept and principle of work and energy in its application to a system of particles. Okay? And of course, hindi mawawala ang pag-solve ng problems related to the principle of work and energy. Okay? So, let's start, no? So, for our part 1, we're going to talk about the work of a force. Medyo, familiar yung work tsaka yung force. So, walang work if walang force and whatever, kung ano pa yung ma-formulate natin later on. No? Ano yung mga principles behind this one? Okay? So, the work of force, in this lesson, we will use the concepts of work and energy to analyze the motion of particles. No? And lang, we are going to analyze the motion of a particle na magagamit natin to know what are the concepts behind work and energy. Ano ba yung mga concept doon? So, let's analyze it. So, by definition, work is the measure of energy transfer, energy transfer, that occurs when a particle or a body is moved over a distance by an external force, at least part of which is applied in the direction of the displacement. So, again, basically, kumbaga, yung distance or the displacement of a certain particle or a body na displace because of that certain work, that certain force, tinatawag natin yung work, It is a measure of energy transfer. Energy transfer, na nag-occur when a body moves for a certain distance, because of an external force na na-apply doon sa specific body. And if it displaced, then there's a work there. Okay, ganun lang baga yung basic concept doon. So specifically, if a force F will do work on a particle or a body, when the particle undergoes a displacement in the direction of the force, applied or external force, Ayan kumbaga, may work yung force if yung particle nag-displace, in the direction of the force applied or an external force. Kumbaga, meron kang positive work na makukuha if if that force can displace that object in the direction or directly proportional or same direction lang, kumbaga, sa in-apply mong force. Kumbaga, if for example, this crane, this crane lifts this say this still, I don't know, cantilever, no? So, kumbaga, in the plane ng crane dito is upward force. And therefore, uh, obviously, mag-displace tong object to magdi-display siya or mag-elevate. Therefore, merong work na nagaganap kasi nga same yung direction ng pag-displace and same din yung force na in-apply natin doon or same din yung direction ng force na in-apply natin sa object natin. So therefore, may work na nagaganap sa system natin. Okay? So that's how your work do. So let's have a very close look kung ano ba talaga tong force or work of a force. So let's consider this figure. Itong figure na to. May particle tayo, may particle na dito, itong circle. And circular na object or this particle. And we have a path S. No? Meron tayong force na in-apply and may displacement from the initial point of the particle R from this point of origin or eto. And then, magde-displace tong particle natin dito sa R prime. So, paano ba to? Paano ba natin i-analyze kung yung work niya na nagaganap there? So, if a force force F is applied on the particle, it will move along the path S from the position R to R prime. Oha? Kumbaga, yung force natin, yung F force or force F natin na in-apply natin sa particle, yung particle daw natin is mag-move along the path S from the initial position R to R prime. Okay? Thus, the particle undergoes a displacement dr. Therefore, this dr is our displacement of the particle after it exerted by a certain force, F. No? And then, dr is equals to R prime minus R. Alam na natin yan. Note that the magnitude of dr is ds, which is the length of the differential segment along the path. No? Ganun lang kasimple. Kung baga differential path niya, if imbes na dr, pwede natin tawagan yung ds kasi yun yung baga differential segment sa along the path natin s. Okay? So we can call it ds. No? Okay? So if the force is being exerted at a certain angle theta, in the case shown in the figure, the angle between the tails of dr and f, then the work done with the force F is a scalar quantity defined by du or work, U is work So du or differential work is equals to the force times ds times cosine theta. Kasi nga, kukunin natin dito is yung yung adjacent side ng force natin. Kumbaga, dalawa to may 'di ba? May dalawa components to. Yung let's say if we have our axis here, so we have our y component and x component of our force, di ba? So, sabi dito, if a force is being exerted at a certain angle theta, in the case shown in the figure, the angle between the tails of dr and f, then the work done by a force, F is a scalar quantity defined by this one. So, F times ds times cosine theta. So, that's how you solve for your work. No? Differential work at a certain point of our path, along the path, no? Yeah. So, du, by dot product, alam natin to. So, du is equals to F dot dr. Okay? So, where du is the work done by F, F is the applied or external force, and ds, displacement. Take note lang yung, a formula, no? Du is equals to F ds cosine theta. That's how you solve for your work, no? Force times the displacement times cosine theta. Okay. Equation 7.1.1, no, can be interpreted either one, no, as the product of the F and the component of displacement ds cosine theta and the direction of the force. Okay? Take note as the product of F and component of the displacement ds cosine theta and the direction of the force. Now, there's another one. As the product, no, equation 7.1.1 can be interpreted as the product of ds and the component of the force F cosine theta in the direction of the displacement. So, pwedeng pamili kayo sa dalawang let's say, variable natin. Kung baga, or figures natin, no? If you want to be, to define or to interpret your work to be the displacement or the component of the displacement or the component of the force. So, kayo na naman mamili doon kung asan yung mas madali, no? Pwede siyang, again, pwede siyang F times the component of the displacement, no? Which is ds cosine theta, or the product of the displacement and the component of force, which is F cosine theta. Ganun lang. So, pwede siyang ganun. So, note that if our theta is greater than or equal to 0 degrees, but less than 90 degrees, the force component and displacement have the same sense. Thus, the work is positive. Diba? As you can see here, if we say, basta more than, more than 0 or equal to 0, meron siyang work na mabibigay, di ba? Kasi nga, same yung, direction of force and the displacement itself, no? So, if we say, for example, our theta here is in between of this given range, let's say 45. So, meron siyang work. Now, basta below siya ng 90 and greater than or equal to 0, your work will be positive. Kasi nga, as the definition of the work is, mayroon siyang work if our force and displacement in the same direction, no? Diba? Ganun lang ka-simple. Kasi kung more than 90 to, whereas if your theta is greater than 90 degrees, but less than or equal to 180, the force component and the displacement will have opposite sense, and therefore the work is negative. Kasi nga, yung displacement mo para right, tapos yung force mo para left. Baliktad. Yung displacement mo is pa left, and then your work is pa right. So, walang work na magaganap doon. But instead, it's a negative work, no? So, also, work is 0, du is equals to 0, no? If the force is perpendicular to the displacement, ds, since cosine 90 is equal to 0, or if the force is applied at a fixed point, in which case the displacement is 0. Kumbaga, if your force is perpendicular to the displacement, walang work na nagaganap, or yung displacement mo is 0, or your force is applied in a fixed point lang, na wala siyang displacement, so therefore wala siyang work din. Okay? So that's how your concepts na work natin, no? That's how your work does, no? The unit of work can be joule, no, J or Newton meter in SI units. Note that 1 joules is equals to 1 Newton meter. And for FPS system naman is foot pounds. Okay? But take note, class, if we say foot pound, work yun. But if we say pounds foot, kabaliktaran na, pounds foot ha, that will be your torque or your moment. Take note, if we say foot pounds, that's your work. But if we say pound foot, that's your moment or torque. Take note lang ha. That's how your work here sa work. That's how your work works. Okay? So, foot pound yung FPS system. Okay? Remember that one. So, what if your work is a variable force? So, if a particle acted upon on the force F undergoes a finite displacement along its path from R sub 1 to R sub 2. Ito yung R sub 1 natin, R sub 2. Okay? S sub 1 to S sub 2. Ito yung S sub 1 natin, S sub 2. As shown in the figure, the work of the force, no? The work of force F is determined by integration. Okay? Kasi nga variable siya. So, we need to have that segment along its path, and then we integrate para makuha natin yung whole segment. Okay? So, if your force again is variable, you can compute your work using integration. No? This is u from 1 to 2 is equals to the integral of f dr from r sub 1 to r sub 2. No? Or equal to f cosine theta ds from s sub 1 to s sub 2. Take note, if dr r yung gagamitin mo and ds s yung gagamitin mo. So this is how you solve for a variable force. Integration lang. Kasi yun lang talaga yung pattern. No? If variable yung you were going to use talaga integration so that you can solve for all the segment kahit anong curve pa yan, basta integration mo, solve mo yan. Okay? Okay. Now, there's also a experimental data, no? Ito yung equation mo or your formula. It can also be obtained by using experimental data and plotting it on a f cosine theta versus s graph. Ito yung f cosine theta na axis mo and then ito yung s graph. No, s axis mo. Okay? As shown in the figure. So, the area under the graph or this graph, no, bounded by s sub 1 to s sub 2 represents the total work. Take note ha. You can obtain your work using experimental data and plot all of those data, no? If makakabuo ka niya ng curve. Tapos, yung given na S sub 1, S sub 2 mo, or your position 1 and position 2, yun yung mga boundaries mo, kumbaga. So, yung area bounded by that, by that limits, no? Ito yung S sub 1, tapos yung curve mo. Kumbaga, magka-create area under the curve, no? If you already got your integral calculus. When we are going to determine the area under a curve, magkukuha ka ng isang segment or rectangular strip from that area of that curve. Tapos, i-integrate mo from this point to this point. So that you can have this whole area. Kung ano ba yung area na Kumbaga, from this strip, since this is rectangular, you can solve for this area to be f cosine theta times ds. That's your length times width, no? When we are going to determine the area of a rectangle. Length times width lang. And then your length here is f cosine theta, and your width here is ds. So that's how you solve for this strip. But how about for the whole? So therefore, using this area of that rectangle, you can integrate from this point to this point so that you can have this whole area, kumbaga. So, ganun lang yung point dito, no? Bakit, sir, saan ba galing to? Ito yung formula. Paano nyo ba kinuha yan? So, this came from this. Yeah, yan lang. Okay? So, what if your force is constant, no? And moving along a straight line? Paano ba yan? So, if a force F sub c has a constant magnitude and acts at a constant angle, theta, from its straight line path, as shown in the figure, then the component of the F sub c and the direction of the displacement is always F sub c cosine theta. Thus, the work done by F sub c when the particle is displaced from S sub 1 to S sub 2 will be this one. So, di ba? Constant yung force tsaka theta mo. So, ilalabas mo yan from this, So, therefore, ds na yung matitira. Therefore, the integral of ds is s. Tapos, therefore, your integration of your ds is s sub 2 minus s sub 1 na lang after you integrate that. Therefore, your work, if your force is constant and moving along the straight line, you can solve for your work to be equal to F times cosine theta times S sub 2 minus M sub 1. So, nanggaling lang din dun sa 7.1.2 na formula natin. But, ang difference lang dito is, ayun nga, constant na yung force tsaka yung theta. And then, by plotting all of those makaka-form tayo ng rectangle na curve. So, simple na lang, FC cosine theta times yung width niya dito, which is the difference between the S sub 2 and S sub 1. Therefore, you can get your whole area of this curve. Therefore, you can have your work. Okay? So, that's how you solve for your work if your force is constant and moving along straight line. Okay? Now, what is the work of a wave? So, consider this figure. Meron tayong weight natin dito is pa downwards, and then yung displacement natin is pa upward. Take note ha. Displacement natin dito is from S sub 1, from Y sub 1, and Y sub 2. Okay? From along, y-axis natin yung movement dito pa up and down kasi nga, downwards lang din yung yung weight natin. So, therefore, yung particle natin dito is nag-move siya pa upward. Kasi nga, from Y sub 1, nag-elevate siya from y sub 1, nag-elevate siya to y sub 2. Therefore, your displacement is upward. What will happen here? So at an intermediate point, the displacement is yung d sub r mo, or dr rather, is equals to dxi plus dyj plus dzk. Diba? We are talking about vector quantity here. Now, since F is equals to W, no, the weight is the only force that acting on our particle. Kasi nga, meron naman talagang weight yung H na natin kasi may mass. Tapos, nandito tayo sa Earth, there is a gravity, no? Pwera na lang kung nasa vacuum siya. So, ang dami ko nang sinasabi. Basta, yung F mo is equals to weight and equal to negative Wj. Kasi nga, acts downward eh. Tapos, applying equation 7.1.2, we have u sub 1 minus 2, or u sub 1 to 2 is equals to the integral of f dr is equals to integral of wj times the dot product dx sub I, dxi plus dyj plus dzk from r sub 1 to r sub 2. And therefore, u sub 1 to 2 is equals to the integral of negative y dy from y sub 1 to y sub 2, which is equals to negative w times y sub 2 minus y sub 1. So that's how you solve for your work of a weight. Okay? So, therefore, u sub 1 to 2 is equals to negative w or change of y. Diba? Ito lang kumbaga, delta y. This is the change, no? Change of y sub 2 to y sub 1. So that's how you solve for your work of a weight. Diba? So based on equation 7.1.4, the work is independent of the path and is equal to the magnitude of the particle's weight times its vertical displacement. Ulitin natin. So the work is independent of the path and is equal to the magnitude of the particle's weight times its vertical displacement. Kumbaga, di ba? Sige nga. 7.1.4 na equation, which is eto. Etong equation na to, negative w times the delta y. Sabi is, ang work daw natin is independent of the path, no? Hindi siya nag-ano siya sa path. Kasi nga, is equal to the magnitude of the particle's weight times its vertical displacement. Now, also shown in the figure, the work is negative since w is downward and delta y is upward. Which is makes sense, di ba? Negative yung work always natin when we are talking about work of a weight. Kasi nga, dito, sa figure natin is opposing yung natin, directions ng force tsaka yung displacement ng natin, particle dito. So therefore, magiging negative din yung work natin as we defined kanina. What is work now? So however, if the particle is displaced downward, negative delta y, the work of the weight is positive. Kasi nga, negative times negative, di ba? Positive. So, your work will be positive na. Kasi, pa-downward din yung displacement mo. So, there's work positive there. Kasi nga, same ng direction yung force natin tsaka sa pag-displace ng particle natin. So, that's makes sense also. Di ba? Now, what if the spring force? Ano yung work ng spring force natin? So, I hope nag-gets na yung work. Bakit? Ang work of a weight. Bakit negative yung W natin? Kasi nga, discuss na natin like kanina. Okay? So, if an elastic spring is elongated a distance ds at a distance ds as shown in the figure A, eto. Kumbaga, inelongate natin from S to ds. No? Inelongate natin siya. Then the work done by the force that acts on the attached particle is equal to negative F sub S ds. Okay? Spring force yung tawag dito sa F sub S ha. And then, when solving for our spring force, we need to multiply our K times S ds. The work is negative since F of S, or F sub S, acts in an opposite sense to ds. Kasi nga, if we elongate this one, we are applying yung ano natin, di ba, bumabalik if we stretch this spring force. So therefore, yung force natin is pa right, but we elongate that. So yung displacement niya is pa right. So negative yung ano natin dito kasi nga if we release that one, yung force or yung force na i-exert ng spring back to the particle kasi nga in-elongate natin yung spring. So therefore, magiging opposite sa direction sa pag-stretch natin. Therefore, it will give you a negative work. Okay? And how to solve for your work again is negative k times s ds. Okay? So if the particle displaced from s sub 1 to s sub 2, from s sub 1 to s sub 2, then the integrating equation 7.1.5, the work of f of s is, ayan. So, integral of du is equals to negative the integral of ks ds from s sub 1 to s sub 2. Therefore, your u sub 1 to 2 is equals to negative, kasi nga, s ds is s squared over 2. So, that will be 1 half ks sub 2 squared minus 1 half ks sub 1 squared. Okay? Therefore, your result will be work from 1 to 2 is equals to negative 1 half k s sub 2 squared minus s sub 1 squared. So that's how you solve for your work of the spring force. Negative din siya kasi nga opposing. Just like the weight. Okay? So this is how you solve for your spring force. So the work of f of s or equation f sub s or equation 7.1.6 represents that the trapezoidal area under the f sub s is equals to k s shown in the figure at the bottom. Ito. Okay? Note that if the spring force acting on a particle in the direction of the displacement of the particle has same sense, then the work is positive. Diba? If they are opposite, then then the work is negative. Ganun lang kasimple yung spring force natin. Basta ang importante, alam nyo yung kung paano mag-compute ng work ng spring force, work ng weight niya, at saka work ng force na na-apply natin doon. Okay? So let's have an example. So there's a 10 kilogram block shown in the figure. Ito yung natin. Rests on the smooth incline. Ito, smooth incline. If the spring is originally stretched 0.5 meters. Determine the total work done by all the forces acting on the block when the horizontal force P is equals to 400 Newton pushes the block up the plane S is equals to 2 meters. Kumbaga, meron tayong ditong spring. Pinush pa natin ng 400 Newton hanggang umabot siya sa S is equals to 2 meters. Ayan. So, ano yung work natin dito? The total work done by all of the forces acting on our block. So, that's how yung given, yung figure natin. Tapos yung mass ng block is 10 kilograms. Yung initial position natin is 0.5 and then yung pulling force natin is 400 Newton. And we are required to find the total work done by all the forces acting on the block or U sub T. Okay? So, ano yung gagawin natin una? Of course, we are going to draw the free body diagram of the block to show all the forces that act on our block. Okay? So this is your FBD. This is your weight. This is 10 kilograms times 9.81. So that will be 98.1 Newton. 30 degrees from the vertical, no? Kasi yung axis natin dito is pa-implanted, 30 degrees. And then, yung normal, kasi meron siyang weight, meron dapat siyang normal na against sa inclined plane natin. Then, the pushing force, no? Di ba, pinush ng isang 400 Newton ang block natin. So, meron din yung 400. Tapos, dito, 10 is the spring force. Kasi nga, in-stretch natin doon initially yung spring natin. Therefore, meron siyang spring force na ma-experience pabalik. Okay? So then compute the work done of each force that acts on the block. Now, for our horizontal force, ano yung mga horizontal force na nag-act sa block natin? Since this force is constant, we will apply equation 7.1.3. Meron tayong constant kasi nga constant yung force natin, tapos na straight line path yung movement or displacement. So therefore we can use the 7.1.3, which is u from what the work from 1 to 2 is equals to F cosine theta, no? Times S, diba? Fs cosine theta, no? This is your S sub 2 minus F sub 1. So that will be the work of the force, of the horizontal force P, no? F is cosine theta times S sub 2 minus S sub 1. That will be P cosine theta S, no? And then U sub V is equals to 400 Newton cosine 30 degrees. Kasi ito, yung theta natin is 30 degrees from the horizontal. That will be times 2 meters kasi ito yung distance natin, or the displacement rather, ng block natin from its initial point. So therefore, the work done by the force natin dito is 692.82 joules for our horizontal force, no? For our spring force naman, applies equation 7.1.6. That will be U sub S is equals to negative 1/2 K times S sub 2 squared minus S sub 1 squared. Where your S sub 1 is 0.5, initial position of the spring. And then S sub 2 is equals to 0.5 plus 2. So that will be 2.5. Final position of the spring. Therefore, your U sub S is equals to negative 1/2, 13 Newton over meter. That will be your K for a spring, no? 30 Newton over meter. So it will be 2.5 squared minus 0.5 squared. Therefore, your spring force or spring work done sa spring natin is negative 90 joules. How about yung weight? Meron din tayong weight, di ba? So apply 7.1.4 and work done should be negative since the weight W acts in an opposite sense, so it's vertical displacement. So that will be U sub W is equals to negative W delta Y is equals to negative W S sine theta. Okay? So it will be negative 10 kilograms times 9.81 meters per second squared, 2 meters times sine 30. Diba? Sine 30. So that will be negative 98.1 joules. So, na-compute na natin lahat ng force and meron pa lang normal force, no? We have this work thus no work, U sub N sub B is equals to 0 since it is always perpendicular to the displacement, no? U sub N sub B is equals to N sub B cosine theta, which is theta is 90 degrees, therefore cosine 90 is 0, so N sub B times 0 is 0. So wala siyang work done sa normal force. Okay? Therefore, the total work will be sum all the work done by the forces acting on the block. That will be U sub T is equals to the work of the force, work of the spring force, work of the weight, plus work of the normal force. Therefore, your horizontal force P, that will be 692.82 joules. Your work done by your spring force is negative 90 joules. And the work done by the weight is 98.1. Therefore, your work or total work done by all the forces that acting on our block will be 504.72 joules. So, ganun lang kasimple yung pag-compute natin ng work. So, I hope you did learn something. So, let's proceed naman. So, ano ba yung mga principle ng work and energy natin? Ano ba ang relationship nila? So, for our part 2, we will going to discuss the principle of work and energy. Okay. So, consider the particle shown in the figure, which is located on the path defined relative to an inertial coordinate systems. Okay, ito yung particle natin. This is your position 1 and position 2. And then yung F of R, or resultant force, is equal to all of the forces, no? Dito yung normal force natin, tsaka tangential force natin, no? Kasi nga, it is moving on a curve, on a path, so meron siyang tangential and normal, no? Tapos meron din tayong displacement dito, and then velocity, no? And the degrees from, or the angle from our resultant force to our tangential force. Okay, so if the particle has a mass m and subjected to a system of external forces represented by the resultant F sub r is equals to summation of all the forces, then the equation of motion for the particle in tangential direction is, ayan, so all sum of all the forces in the tangential direction is equals to m times the tangential component of the acceleration. Okay, so applying the kinetic equation, so a sub t ds is equals to v dv, and integrating both sides, assuming initially that the particle has a position s is equals to s sub 1, and a speed of v is equals to v sub 1, and the final position at s is equals to s sub 2, and the final velocity of v is equals to v sub 2, we have, ayan, so this is your, from our kinetic equation, at ds is equals to v dv. So that will be at is equals to v dv over ds. That will be, substitute natin dito sa force natin, that will be the summation of all the forces or tangential forces is equals to mass times the a sub t, which is equals to v dv over ds. So dito yun na mangyayari. So that will be summation of all the tangential forces divided ds is equals to m v dv. So, ano lang natin, multiply natin both sides by ds para ma-cancel out dito yung ds sa right side natin. So, mapunta dito yung ds sa left side. Therefore, ano mangyayari? We're going to integrate both sides from s sub 1 to s sub 2 sa left side and v sub 1 to v sub 2 sa right side natin. So, that will be the summation of all forces ds, the summation of all the integral of f sub t ds from s sub 1 to s sub 2 is equal to integral of mv dv from v sub 1 to v sub 2. That will be, yan. Same pa rin. That will be your, yan. So, then the summation of all integral of f sub t ds from s sub 1 to s sub 2 is equals to, kasi nga, v dv, the integral of v is v squared over 2, so that will be this one. Evaluating from v sub 1 to v sub 2. So, therefore, yung ganito siya. Is equals to 1 half, nilabas natin yung 1 half, m times m v sub 2 squared minus v sub 1 squared. Ito na siya. Note that the summation of all f sub t is equal to the summation of f cosine theta as shown na figure. Ayan. Ito lang kumbaga, di ba? Cosine theta ng ano natin, summation of all the forces, cosine theta. Ito yung tangential for all of the forces, or summation of all the forces in tangential, cosine theta lang siya. Multiply na natin ng cosine theta, therefore equal lang din siya sa tangential component ng force natin. Diba? So that's how you solve for our S sub t. Therefore, we can use our work here. We can relate the work here. So we have u sub 1 to 2 is equals to integral of f cosine theta ds from s sub 1 to s sub 2. Simplifying, we have, ayan, so from this one, so this one, di ba? Kumbaga, ito lang yung work, kumbaga, summation of all the works ng dito. Kasi nga, this is how we solve our work, di ba? F cosine theta ds, so that will be your work. And integral from s sub 1, ito yung equation 7.1.4 natin, di ba? Ito yung sa right, sa left side natin. Therefore, your principle of work pala and energy, specifically kinetic energy, kasi involved ng velocity natin dito, we can call it the kinetic energy. So ito yung principle of work and energy natin. So summation of all the work from 1 to 2 will be equal to the initial kinetic energy, final kinetic energy minus the initial kinetic energy. So that will be 1 half mv sub 2 squared minus 1 half mv sub 1 squared. Okay? So the equation 7.2.1 represents the principle of work and energy for the particle. So ito lang kumbaga yung principle of work and energy natin, formula. So the term or equation, the term on the left, the summation of all the work from 1 to 2 is the sum of the work done by all forces acting on the particle as the particle moves from point 1 to point 2. Ano kung mahaba-haba, but let's detect Technically, ganun lang tayo siya pagbasa. Okay? Sum of the work done by all forces acting on the particle as the particle moves from point 1 to point 2. Okay? While the terms on the right side define the particle's final and kinetic energy T respectively and can be written as ito. Pwede natin kinetic energy T. So we can rewrite this to T sub 1, yung m1 half mv sub 1 square. Okay? We can rewrite that one. And ito that sa final natin. Again, yung right side natin, define the particle's final and initial kinetic energy respectively. Okay? So for our initial, we can name that or we can written that by T sub 1 and T sub 2 naman sa final natin, final kinetic energy. Like work, kinetic energy is a scalar and has joules and SI, foot-pound, and FPS system. Kaya lang. So work can either be positive or negative, but kinetic energy is always positive regardless sa direction of the motion of the particle because squared palagi yung velocity dito. Kahit negative po yan, kung paano siya, pa right or against the force or the path, no? We squared lang din naman, so squared of either positive or negative, positive lang naman din yung resulting. So we can always remember or note that kinetic energy is always a positive number. Okay? Or result, no? So that's how your kinetic energy. So expressing equation 7.2.1 in terms of kinetic energy symbol, then we can have from this to this. Okay? Hindi ka na dito doon. So 1 half mv sub 2 squared is T sub 2. And 1 half mv sub 1 sub 1 squared is T sub 1. So, sige, gano'n lang talaga yung pag-anyo. So, sinubstitute lang natin yung symbol na T sa kinetic energy kasi nga kinetic energy lang din to. So, we can that. So, we can rewrite this from T sub 1 plus the summation of all the work done by the forces when your particle moves from 1 to 2 is equals to the final kinetic energy. So, equation 7.2.2 states that the particle's initial kinetic energy plus the work done by all the forces, yan, yung right na left side natin, initial kinetic energy plus the work done by all the forces acting on the particle as it moves from its initial to final position is equal to the particle's final kinetic energy. So, ganun lang kasimple. Okay? So, ano ba yung mga procedure of analysis and key points natin dito when we are going to solve principle of work and energy? So first, identify the given and announce the problem. That's your first thing to do, no? Kailangan nyo identify yung given and announce ng problem. Tapos, establish the inertial coordinate system and draw the free body diagram. Inertial coordinate system para malaman natin kung ano yung direksyon, kung asan papunta yung particle natin as we consider the force and the acceleration that are existing on our particle. Tapos, after nyo mag-establish ng inertial coordinate system, draw na yung FBD or the free body diagram to account all the forces that do work on the particle as it moves along its path. Kasi, what if nag-ano ka lang, na-imagine, ito yung mga work. What if makakaligtaan mo yung isang work o yung isang force? So, hindi mo ma-account lahat ng work doon or lahat ng forces na nag-act upon. So, therefore, may iba yung work done by all the forces they exerted in the body. So, just for safety, no? Or double check na lang. Dapat makadraw ka ng free body diagram. So, apply the principle of work and energy, which is ito. No? Ito yun. Or you can use this formula instead. But this is more like, ako na bahala kung ano yung gagamit nyo dyan. Okay? After you apply, kinetic energy of the particle at both initial and final points or position is always positive because it involves the speed squared that is this one. Kaya, yun nga sinabi ko, always positive yung kinetic energy natin kasi nga speed squared. So, yeah, always positive lang siya. A force F does work when it moves through a displacement in the direction of the force. Take note that one. So, if opposite yung direction ng force mo sa displacement mo, no, there's no work at all. or negative. So work is positive when the force component is in the same sense of the direction as the displacement. Otherwise, it is negative. Yan lang kasimple. Ang mga key points natin dito when we are talking about work and energy there. So forces that are functions of displacement, must be integrated to obtain the work. It can be represented by graphing where the work is equal to the area under the force displacement curve. Yan lang kasimple. Kumbaga, you can represent the graphing by graphing yung work mo, no? Kung meron ka force at displacement na mga data mo. So, you can draw your graph. Okay? So, the work of a weight, U sub W, is the product of the weight of the particle and the vertical displacement. That is, ayan. Again, kung same sense yung direction ng weight tsaka displacement mo, positive yung work of weight mo. If opposite, negative. Okay? Ayan lang. It is positive when the weight moves downward or same with the sense of the displacement. Ganun lang kasimple. So the work of the spring can be determined using the formula 1/2 ks squared. Usually given yung k natin where your k is the spring stiffness. So meron siyang mga constant, no? Na ibigay kung ano yung k ng problem na yun. So you can already solve that using this formula. Okay? It is negative if the force of component and displacement has opposite sense and direction. Same sense lang din sa mga key points natin kanina. So I think that's all for your power, that's no power. Principle of work and energy. Basically, in-explain lang natin or dinerive lang natin kung saan nanggaling yung principle of work and energy. Diba? Again, yung principle of work and energy is T sub 1 plus, no, the sum of all the work done where all of the force is exerted on the body is equals to the final kinetic energy. Ganun lang. So, part 3 will be your principle of work and energy for a system of particles. Kung ano yung mga principle of work and energy na gagamitin if your system composed of if you're dealing with system of particles. So, ano yung bang mga dapat i-consider natin? Okay. So, consider this figure. The principle of work and energy can be extended considering a system of particles isolated within a closed region of space shown in the figure. Yung mga particles mo dito, meron siyang normal, tsaka tangential axis, meron kang force dito, tsaka meron kang external forces, tsaka internal forces, yung small letter f sub I, tapos ito yung particle I natin, tapos yung path ng ating particle I. So this is your inertial coordinate system. Now, consider an arbitrary ith particle, ito yon, shown in the figure, having a mass and is subjected to a resultant external force, F sub I, and a resultant internal force, F sub small letter f sub I, which all of the particles other parts exert on ith particle. Kumbaga, yung mga particles na nasa system natin, may ina-exert na internal force sa ith particle natin. So, dapat natin din yung consider. Okay? Now, dalawang force na na-exert natin dito, yung external tsaka yung internal. Yung external is denoted by the capital letter F and yung internal is small letter f. Okay? Take note that one. Applying the principle of work and energy to the ith particle and each of the other particles in the system, the equation can be summed algebraically. That is, ayan. So we can sum all of the natin dito, initial kinetic energy ng mga particles natin doon, initial na and then we can sum up all of that. Okay? So equation 7.3.1 states that the initial kinetic energy of the system plus the work done by all the external and internal forces, hindi lang external, meron din siyang internal take note lang that, acting on the system is equal to the final kinetic energy of the system. Same lang pa rin sa principle of work and energy, but meron na involve ng mga or we are using system na, hindi na particle. Okay? So, meron na siyang mag-exist na internal forces kasi nga, may na-exert na rin in between or mga interactions or reaction and action din sa loob ng system natin kasi nga hindi lang particle na nandun, system of particles na nandun. So, meron natin i-consider na internal forces. That will be change the whole concept of the principle of work when we are talking about particles lang or we are talking about system of particles na. Okay? Pero same lang din yung formula natin na kailangan natin i-consider. Ito lang din yun. Okay? Ang difference lang is we're going to sum all of the particles inside the system and we can get our kinetic energy from the initial and its final point. Okay? So consider, for instance, a block which is it's translating a distance s over a rough surface and as shown in the figure ito from this point to this point. Tapos figure A ha. Tingnan figure A natin. Focus lang dito na muna tayo ha. So if the applied force P just balances the resultant friction of force, F sub F is equals to mu sub K times N as shown in the figure. Ayan, D. Ito yung free body diagram niya. Meron siyang force. Meron siyang normal kasi meron weight. Tsaka yung may friction siya. Kasi nga rough surface. So, dapat na-consider natin yung friction. Then, due to equilibrium, a constant velocity is maintained. Okay? So, due to equilibrium, yung velocity natin is maintained. No? Applying 7.3.1, we have, ayan. Ito yung natin, di ba? 7.3.1. Therefore, magiging siya, 1/2 mv squared plus p times s minus mu k. Kasi nga, ito yung mga work done mo sa mga, di ba? May, may pulling force, meron kang UK. Take note, ito lang yung mu k, yung horizontal na, natin. Kasi nga, perpendicular yung weight tsaka yung normal lang dito. Kasi nga, horizontal lang siya. So, yung makakonsider lang mo dito is, yung normal is perpendicular to the displacement or the movement of the system. And tapos yung weight mo pa rin, perpendicular, therefore wala silang mga work doon. So, makakonsider lang natin dito ng mga nagwo-work o yung mayroong work done na nangyayari is your friction and your force. Okay? Kasi, gets na yun, di ba? Horizontal force yung kailangan natin i-account. So, dalawa lang. Wala yung normal tsaka yung weight natin dito. So, is equals to the final na kinetic energy which is 1/2 mv squared. Okay. So, what will happen here? So, 1/2 mv sub 1 squared plus ps, your horizontal force P times S, kasi ito yung pag-solve ng work natin, force times the distance, no? Minus, since cosine 0 is 1, so hindi na kailangan natin ilagay doon cosine 0, o cosine theta, or cosine 0, kasi nga cosine 0 is 1, no? So we can just write here PS, no? Directly. Hindi natin kailangan pinaulit ko na. So minus, bakit negative to? Kasi nga opposing yung direction ng friction natin. So that would be negative work. Kasi nga pa-left yung friction force mo na nag-apply doon, tapos yung movement or your displacement is pa-right. Therefore opposing sense, therefore negative yung work mo. So that will be negative. And your final kinetic energy, that will be 1/2 mv sub 2 squared. Therefore, note that equation 7.3.1 or 7.3.2 can be applied to problems involving sliding friction, but it should be realized that the work of the resultant friction F sub F is not represented by mu sub K and S. Instead, it is represented by both external work of friction, which is mu sub K n times S sub S prime, and internal work of mu K n times S minus S prime. Okay? Always take note na dapat kung mag-involve tayo ng sliding friction, it should be realized that the work of the friction force or the resultant friction is not represented by ito lang. Instead, it is represented by both an external work tsaka internal work. Okay? So that will be mu sub k and s prime, and eto, internal work mo na mu sub k and times s minus s prime. I know you're confused, but you can elaborate that in our example. No? Speaking of example, let's have an example. Okay, so the 3,500 pounds automobile shown in the figure below travels down the 10-degree inclined road at speed of 20 feet per second. If driver jams on the brakes, causing his wheels to lock, determine how far as the tires skid on the road. The coefficient of friction between the wheels and the road is mu sub k is equals to 0.5. So, given is your figure, then your weight of the car is 3,500 pounds. Your theta is 10 degrees. Your velocity is 20 feet per second, and your mu sub k is 0.5. And we are required to find the distance or how far the tires skid on the road. Okay, so solution. So draw the free body diagram to show all the forces and reaction acting on the automobile. Ito yun. Meron kang weight, meron kang friction force at A, and then normal weight. No, normal force, rather. So first the normal force n sub A, but note that it has no work since it is perpendicular to the displacement. We only need this force to solve friction force. Yan. Kailangan lang natin ng n sub A para makakuha natin yung f sub A. Ano ba yun? So, summation of all the forces at normal is equal to 0. That will be n sub A minus w cosine 10 degrees. So that will be your n sub A will be equal to 3,500 cosine 10 degrees. That will be 3,446.83 pounds. So this is your normal force, no? Acting on our car. So solve friction force. Since nakuha natin yung normal force natin, that will be 0.5 3,000 times 3,446.83 pounds. That will be equal to, your friction force is equal to 1,723.42 pounds. So apply the principle of work and energy equation. Ayan. So kinetic, where your summation of all the work done by all of the forces, no, that will be your weight and your friction. So that will be your F sub F times S. Okay. So therefore, your summation of all the work will be equal to 3,550, your weight, times sine theta, which is 10 degrees, times S, minus 1,723.42 pounds, times S. Therefore, your work, and sum of all the work, or summation of all the work done, is equal to negative 1,106.97 S. Okay? This is unknown pa. And V sub 1 is equal to V, is equal to 20 feet per second. V sub 2 is equal to 0 because the brake up is applied and the automobile will stop at the distances. Kasi nga, brake siya, will stop at a certain distance now. So wala siyang V sub 2 or wala siyang final velocity kasi nga, patuot na ako, so that will be equal to 0. Now, ang mangyayari will be your final kinetic energy will be 0 kasi nga wala na siyang velocity doon. So that will be 0. So mangyayari, your initial kinetic energy, that will be 1/2 3,500 pounds divided by 32.2 feet per second squared kasi nga we're talking about the mass here. So we need the mass. So 20 feet per second, so will be your velocity, minus your work done will be 1,106.97 S is equals to 0. No? So, solving for your S, that will be your S is equals to 19.64 feet. So, ito lang pag-solve ng yung yung distance. Ito yung distance na cover na after you apply brake. No? Ayan lang. Okay. So, the distance S can also be solved by applying the equations of motion with respect to the direction of the displacement and using one of the kinematic equation with constant acceleration. So, ayan. So that will be all forces is equals to m times acceleration. That will be w times sine theta, sine 10 degrees minus f sub a is equals to m times acceleration. So that will be 3,500 sine 10 minus 1723.42. That will be your friction is equals to 3,500 over 32.2. So your acceleration will be this one. It decelerates kasi nga negative. Which is, ano naman kasi nga, yung final velocity mo is 0. So, the change of the velocity will be negative. Pahina. Kasi nga, nagbe-break ka, di ba? So, that will be your acceleration. So, then, since a sub s is constant, this deceleration, we can apply this one. Kinematic equations natin. So, that will be v squared is equals to v sub o squared plus 2a sub c minus times s minus s sub o. Where your final velocity is 0 kasi nga nag-break. 20 feet per second squared kasi nga initial velocity natin plus 2 times yung acceleration natin negative 10.264 feet per second squared times s minus 0 kasi nga initial position is 0. And that will be equal to 19.49 as well. So that's how you solve for your distance, no? Using the principle of work and energy for a systems of particles and the equations of motion, no? So I think that's all for this video, and up next will be your part 2 kasi nga may part 2 pa dito. Meron tayong mag-discuss natin doon sa power and efficiency and the conservation of force. And I hope you did learn something from this, and see you next week.